Welcome back. In this video we're going to construct a light chaser and learn about the binary number system. We want to have some extra lights to flash, so we're going to upgrade our pick type. I'll go up to Options, select Pick Type, and we're going to select a 20x2. I'll say OK. And if we bring out the digital panel, we can have a look at the chip here. We have 8 inputs, 0 to 7. And we have 8 outputs, 0 to 7, in the opposite direction. You'll notice that the inputs start at 0 and the outputs start at 0 instead of 1. This is because the numbering of the pins is based on their binary value. We'll take a little detour in the next clip to look at the binary number system. Numbers that we use every day are based on the decimal system. The decimal system is a base 10 system. A base 10 system has 10 unique symbols, the numbers 0 to 9. A base 10 system has place values that go up by a factor of 10 for each place value as we move to the left in the number, as you'll see in the next slide. If we look at the decimal number 127, we can break it down into its place values. The leftmost place value is 1 times 100, or 1 times 10 raised to the power of 2. And then in the tens column we have 2 times 10, or 2 times 10 raised to the power of 1. And in the ones column we have 7 times 1, or 7 times 10 raised to the power of 0. The internal numbering scheme of a microcontroller is binary. The binary system is a base 2 system. A base 2 system has 2 unique symbols, the numbers 0 and 1. Sometimes instead of saying 1 or 0, we say high or low, or on or off. The place values of a binary number go up by a factor of 2. We'll take a look at that in the next slide. Let's take a look at the place values in this binary number, 101. The lowest value is 2 to the 0, and then we have 2 to the 1 and 2 to the 2. The numbers 0, 1, and 2 will appear on the pins of the microcontroller. 2 to the 0 has a value of 1, so this is the ones column. And then the next bit has a value of 2 to the 1, or 2, which is twice this value. And then the next bit has a value of 2 to the 2, or 4, which is twice this value. So if we wanted to represent this as a decimal number, we could start at the left side and say this has a value of 1 times 4, this has a value of 0 times 2, and this has a value of 1 times 1. So if we add up the bits, bit 2, bit 1, and bit 0, we get 4 plus 0 plus 1. So this binary number would have a decimal value of 5. In our light chaser, we want the pattern of the lights to sweep from one side to the other. So we'll turn on pin 0, pin 1, and then pin 2 and pin 3, and so on. In order to do that, we need to send these 7-bit patterns out to the output port of the microcontroller. When we want pin 0 to light up and all the other pins to be off, that we have a 1 in the 2 to the 0s column, or we send the decimal number 1. When we want pin 1 to turn on, we're going to have a 1 in the 2 to the 1 column, or we'll send the decimal number 2. And when we want pin 2 to light up, we need to have a 1 in the 2 to the 2s column, or we'll need to send a 4. So the pattern is pretty simple. In order to get the lights to come on in this sequence, we need to send 1, 2, 4, 8, 16, 32, and 64. So we could just multiply the value we're sending by 2 every time we send a new value. Here's the completed light chaser program. The light travels from bit 0 to bit 6 and starts over again. This program makes use of 2 new commands: the out command from the variable grouping and the multiply operator from inside of the expression command. Let's start off with the out command. I'll grab one from the variables grouping and we'll double click on it to open it up. And it says output variable value to all outputs. so we can send the contents of a variable. We're going to be using the variable p. I chose p because it stands for pattern. But let's just test it using a number. So I'll type in, I want to send the number 1 or 2 to the 0. So we have the bit 0 turn on, and then if I send a 2 or 2 to the 1, we have bit 1, and a 4 or 2 to the 2, we have bit 2, and so on. The largest value we're going to want to send is 2 to the 6, or 64. We'll test that. So those are the range of numbers we want to send, from 1 to 64. Since we're going up by a factor of 2 every time, we need to multiply the pattern by 2. The multiply operator is this little asterisk from this drop-down list. So the new value of p equals the old value of p multiplied by 2. Let's take a run through the program at slow speed. I've got the slider all the way to the right here. So we'll go up to Simulate Run, and we've set 1 into p, so the variable becomes a 1. We output that on the 1 in the ones column. 2 times 1 is 2. 2 is less than 128. So we're going to come back around with the 2 in p and output that. So 1 in the 2's column. And then 2 times 2 is 4. 4 is less than 128, so we get the yes branch. Come back around, and we're going to output the 4. So we'll get a 1 in the 4's column. And then 4 will become 8. 8 is less than 128, and come back around. I'll go to the slider, and we'll speed this up a little bit. And what we're waiting for is the last one to come on. When it comes on, we're going to see a 64 in p. And once that 64 becomes a 128, then we're not going to take the yes branch, because 128 is not less than 128. So we're at 32 now, 64. So we're going to output that 64 over here. The last bit will come on. We'll wait. And now we get the 128, and we get the other branch. And it'll come back around, set p back to 1, and then we'll output the 1, and we'll start all over again. Here's a completed back and forth version of the light chaser. In order to get the light to move from higher bit values to lower bit values, we have to divide instead of multiply. When the bit 0 to bit 6 sequence is done, we want to set the display pattern p to 2 to the 5, or 32. After we display the 32 and do a wait, we want to move on to the next pattern, which will be 16, so we divide by 2. 16 is greater than 1, so we go through the yes branch and come back and display it, and the pattern continues until we finish lighting bit 1, or 2 to the 1. Dividing 2 to the 1 or 2 by 2 gives us a 1. 1 is not greater than 1, so we follow the no branch, and we come around, and the 1 gets displayed as the first number of the next forward sequence.